Around 8,000 years ago, a gigantic tsunami surged across the North Sea, crashing into the coasts of Britain, Scandinavia, and Northern Europe. The disaster began far offshore when an enormous section of the seabed collapsed off the coast of Norway. Known as the Storegga Slides, this event remains the largest submarine landslide ever discovered. During the Ice Age, Britain was connected to Europe by a massive land bridge that we now refer to as Doggerland. For thousands of years, people lived, hunted, and travelled across this vast area. But as sea levels rose after the Ice Age, Doggerland began a slow retreat beneath the waves. Did the Storegga Tsunami finish what the Ice Age had started and finally swallow Doggerland up? Or is the story more complicated than that? And do we know what happened to the Mesolithic hunter-gatherers that lived on the remnants of Doggerland and along the mainland coasts? Surely the tsunami had a catastrophic impact on their world. Let's see what the geological and archaeological evidence tells us. So what exactly was Doggerland? At the height of the last ice age, sea levels were more than 100 meters lower than they are today. Much of what is now the North Sea was dry land, forming a vast landscape that connected Britain to mainland Europe. From the late Pleistocene and through the early Holocene, we refer to this lost world as Doggerland, named after the Dogger Bank, a shallow area of the North Sea that was itself named after the Dutch fishing vessels or doggers that once worked these waters. Far from being a barren plain, much of Doggerland was a rich and diverse environment. Rivers wound across the landscapes, feeding lakes and marshes. Herds of animals roamed its grasslands, and hunter-gatherers lived, hunted, and travelled across this land for thousands of years. Of course, the environment changed as the climate did, but at times it even had forests and extensive vegetation. The evidence for this vanished world has been emerging from the seabed for generations. Fishermen trawling the North Sea have recovered the fossilized remains of Ice Age animals, including mammoths, woolly rhinoceroses, and cave lions. Archaeological investigations have revealed traces of the people who once lived there. Flint tools, bone artifacts, and hunting weapons have all been found under the North Sea, which tells us that this drowned landscape was once home to thriving human communities in the Paleolithic and Mesolithic. Over the last few decades, archaeologists, geologists, and paleoecologists have combined these discoveries with new technologies to reconstruct Doggerland. They are slowly revealing not only what this lost world looked like, but also how it changed over time. Tsunamis are not easy to identify in the geological record. Evidence of the Storegga Tsunami was first discovered in the 1980s in the form of distinctive sediment deposits, and since then, researchers have uncovered much more data. Some particularly intriguing deposits have been found at Castle Street in Scotland and Disvikia in Norway. These sites are notable because the tsunami deposits lie directly above Mesolithic occupation layers. However, it's impossible to say with certainty whether the tsunami destroyed these settlements or whether they had already been abandoned before the wave arrived. As a result, understanding the true impact of the Storegga tsunami on the people who may have experienced it remains a significant challenge. Over the years, researchers have made numerous attempts to reconstruct Doggerland's geological history and to understand what the landscape looked like when the Storegga tsunami arrived. Some scholars argued that most of Doggerland had already disappeared beneath the sea by around 8,000 years ago. Others suggested that a large island still remained and may even have supported human populations. In 2020, a study sought to settle this debate by producing the most detailed reconstruction yet of Doggerland's final stages. Around 10,000 years ago, during the early Holocene, Doggerland stretched from Yorkshire in Britain all the way to Denmark. Its northern boundary was marked by a slightly elevated area, not a mountain range, but a series of low hills known as the Dogger Hills. As sea levels continued to rise after the last ice age, this vast landscape gradually shrank and became increasingly fragmented. By around 9,000 years ago, the Dogger Hills had likely become separated from the mainland, forming what researchers call Dogger Island. Meanwhile, the surrounding landscape was carved up by estuaries, tidal channels, and inlets. Rather than a single continuous landmass, Doggerland had become a complex archipelago of islands and wetlands. This transformation was probably accelerated by the 8.2 kilo-year global cooling event, a period of abrupt climate change associated with additional sea level rise. Between 8,400 and 8,200 years ago, global sea levels rose by somewhere between 1 and 4 meters. By this point, Dogger Island itself had likely been reduced to a shallow sandbank, with only a few small islands and pockets of higher ground remaining above the waves. 7,000 years ago, so roughly 1,150 years after the Storegga Tsunami, Dogger Island had disappeared entirely. Only a scattering of small islands remained, forming what researchers refer to as the Dogger Littoral. Even then, however, the coastlines of Denmark, northwest Germany, the Netherlands, Belgium, and southern Britain still extended much further seaward than they do today. In eastern England, for example, the shoreline of the Wash, that broad bay on the coast of East Anglia, would have stretched tens of kilometers beyond its modern limits. So what impact did the Storegga tsunami actually have? And were its effects temporary or permanent? Researchers have used bathymetric modeling of the North Sea seafloor combined with evidence from tsunami deposits to reconstruct what may have happened. But different research teams have reached different conclusions, resulting in several competing scenarios. The 2020 study I mentioned earlier re-examined these competing ideas in light of their new reconstruction of Doggerland's final stages and fresh geological evidence from the southern North Sea. By comparing the various models against this new data, the authors attempted to determine not only what the tsunami encountered when it arrived, but also whether it was truly a catastrophic event. In one reconstruction, the Dogger Bank had already been submerged by the time the tsunami struck. Without this natural barrier, the wave would have swept directly across the remaining islands of the Dogger archipelago. If this scenario is correct, the consequences for Mesolithic communities living along the coasts could have been devastating. But as we can see from the most recent reconstruction, it doesn't seem likely that the Dogger Bank had already been submerged at the time of the tsunami. Another model suggests that the Dogger Bank was still above water and inhabited when the tsunami arrived. Early versions of this interpretation proposed a catastrophic inundation of the island. However, later revisions painted a less dramatic picture, suggesting that around 35% of the exposed land surface may have been flooded rather than the entire island being overwhelmed. One of the major challenges is that many of the areas most likely to have been affected in the southern North Sea are now underwater. Over thousands of years, isostatic adjustment and rising sea levels have submerged these landscapes, making direct investigation extremely difficult. Archaeologists therefore have to rely on evidence from places where traces of the tsunami survive. Two recent studies examined sites in northeast Britain and northern Norway. In northeast Britain, researchers found that the number of Mesolithic sites appears to decline before the tsunami, before gradually increasing again afterwards. One explanation is that the tsunami scoured the landscape, eroding archaeological remains and making sites harder to detect. A similar pattern has been observed in northern Norway at Vrangafjord, a sheltered east-facing inlet. Although no clear geological evidence of the tsunami has been identified there, the archaeological record shows a decline in sites around the same period. The absence of tsunami deposits may simply reflect the area's protected geography, where wave heights were insufficient to leave a lasting geological signature. Even so, this evidence remains far from conclusive. It tells us little about what happened to the people living on the remnants of Doggerland itself, or the coastal communities of mainland Europe and Britain. The authors of the 2020 study also point out that many earlier models failed to account for the shoaling effect of the Dogger Bank. As a tsunami passes into shallower water, its speed decreases whilst its height increases, which causes the wave to lose energy. The Dogger Bank may therefore have acted as a partial buffer, weakening the tsunami before it reached the waters further south. There is another important consideration. Tsunamis are not permanent floods. After surging inland, the water eventually retreats. Even where inundation occurred, large areas may have re-emerged once the waves subsided. Dense vegetation and coastal wetlands could also have absorbed some of the wave energy, reducing its destructive power. This raises the possibility that rather than a single catastrophic event that instantly erased the last inhabitants of Doggerland, the Storegga tsunami may have been just one episode in a much longer process of environmental change and rising seas that had already been shaping the landscape for centuries. Cores taken from ancient river channels in the southern North Sea have revealed what researchers describe as tsunami-like deposits. Using optically stimulated luminescence dating, these sediments were found to be contemporaneous with the Storegga Slides and the tsunami the collapse generated. Interestingly, similar deposits are absent from nearby cores, even though the site lies around 42 kilometers from the present-day coastline. This suggests that the river valley acted as a natural funnel, concentrating and directing the tsunami's energy. Detailed mapping of the Dogger Bank and other submerged parts of Doggerland has revealed a landscape crisscrossed by former river channels, glacial valleys, and other topographic features. These would have channeled and redirected the incoming water, creating a highly uneven pattern of flooding. In other words, Doggerland was not simply a flat plain waiting to be swept away by a giant wave. It was a complex landscape of hills, wetlands, river valleys, estuaries, and islands. As the tsunami moved across it, some areas may have experienced powerful surges of water, while others may have been partially sheltered by the terrain. The result was likely a patchwork of impacts rather than a single uniform catastrophe across the entire region. Therefore, it's difficult to determine just how Mesolithic communities were affected by the tsunami. However, if the Dogger littoral remained after the wave retreated, and it seems likely that it did, then it may well have survived into the Neolithic. In that case, communities living on these remaining fragments of Doggerland may have witnessed and even taken part in the final spread of farming as agriculture gradually moved into the northwest. I've listed a few interesting open access papers on Doggerland in the description below if you'd like to go into more detail on this. If you missed my video on the altar stone from Stonehenge possibly having travelled halfway there from Scotland as a glacial erratic via Doggerland, go and take a look. The paper I covered is really interesting. Let me know what you think about the Doggerland research in the comments. Thank you for watching, and I'll see you next time.